Hello, this is the luckiest maths teacher in the world, and today we're going to look at the area of a triangle. I know you've already gone through a way to figure out the area of a triangle before, like area equals half base times height. But sometimes we want to find the area of a triangle and we don't know the perpendicular height. So in these cases, there's another formula that we can use. It's area equals a half AB sine C. So it's using trigonometry. So it can be any triangle that we apply this formula to. So similar to how we went through in the sine rule and the cosine rule, it doesn't matter which side you call A, B, and C, as long as angle A is opposite side A, angle B is opposite side B, and angle C is opposite side C. So what this is saying is we can call this side A, this side B, and this side C, and then the angles, which we usually use capital letters, we have big A, big B, and big C. So to find the area of this triangle, I need to know A, B, and angle C. So I need to know two sides and the angle between them. So let's do an example. Let's say I have a triangle like this, and let's say that I am told that this angle here is 30 degrees. I'm told that this side here is 14 units, and the other side is 12, and this side is 20 or something like that. Actually, it couldn't be 20. Let's say it's something like, 9, whatever. So then to find the area of this triangle, I just take the two sides that I have, multiply them together. I multiply by sine of the angle between them. And then, like when I normally find the area of a triangle, I have to divide it by 2. Timesing by half and dividing by 2 is the exact same thing. So if you were to put this in your calculator, and again make sure that your calculator is in degrees, you should get 84 over 2 or 42 units squared. So again, to use this formula, you have to have two sides and the angle between them. Now, I'm going to do an example that is a little more complicated, so please copy this down if you need it. So let's say I want to find the area of this triangle here. Now, the problem is that I don't know the base and perpendicular height, so I can't use the normal formula of half base times height. Now you might think, okay, I could just draw a line down the middle here, divide it into two right-angled triangles. Now I can do that, and I could use trigonometry to find this length here, because I know an angle and a side, right? But I don't really have a way to find out this length here, because unless it is an isosceles triangle, this perpendicular bisector in blue, this line here, it doesn't cut the base in half. So because of all that, this way won't actually work. So I'm going to need to use half AB sine C. Now, this is not an easy question. What makes this a bit harder than the last one is that although I have two sides that are given to me, that's nice and straightforward, this side and this side, I don't know the angle between them. So I'm going to call that angle theta. I need to find what angle theta is to use the formula. So there's no obvious way to find it. But what I can do is I can use the sine rule, firstly, to find this angle here, which I'm going to call alpha. I can use the sine rule pretty easily to find alpha. And once I know alpha, because I know that this angle, and this angle all add to 180, then I can find theta really easily, and I can apply the formula very easily. So my first task is to find this angle here. I can find this angle here because I know its opposite side, and I have another pair of a side and its angle. So I can use the sine rule here. Cosine rule here wouldn't work, because to use the cosine rule to find an angle, you need to know all three sides, which I don't. So let's use the sine rule. Sine alpha over the side its opposite equals sine 48 over the side it is opposite. So then I times each side by 20 and take the sine inverse. So I should get A equals sine inverse of sine 48 times 20 over 18. So I'm just going to put that on my calculator. So when you're putting that on your calculator, it's probably easiest to do the thing in brackets first, get your answer, and then take the sine inverse of it. So the answer I got when I put on my calculator was about 55.7. I'm just rounding it to one decimal place. Doesn't matter if you use two. So because I found alpha, finding theta, the angle in blue, is very easy. So alpha equals 55.7. So theta is just going to be 180 minus the 48 that's already there, minus the 55.7. So that, if I've done this right, will give me 76.3 degrees. So that was the hard part. Recognizing that I couldn't use the half AB sine C formula, I needed to do a little bit of work first. And I've done that. I've now found the angle between the two sides I know. So once I've done that, finding the area is very, very simple. It is just half, or I can divide by 2 at the end, A, B, sine of the angle between them, sine C, and I divide by 2, which is the same as timesing by a half. So I put that on my calculator again. And so the area that I've got from this, when I put this on my calculator, is 100, or approximately 174.9 and units squared, because we weren't told the units, okay? So sometimes you have to do a bit of extra work, but this example shows you how useful the formula half AB sine C can be. So I hope you've enjoyed this video. This has been the luckiest maths teacher in the world. Have a great day.